Alrighty, so let's do one more sketching application. Example 8. So we need to sketch the graph of 2x e to the x for the domain of x is less than or equal to 1, showing all the important features, blah blah blah. Alright, so this one's a little bit trickier because it's not your normal polynomial, it involves some sort of exponential as well. So let's write down our function. I don't like f of x, so I'm just going to say y equals 2x times e to the x for the domain x is less than or equal to 1. So first of all, work out your first derivative so that we can work out the stationary points, and then we need to look at the double derivative so that we can look at the concavity. So because this function has 2x times e to the x, we need to use the product rule to differentiate once. So using product rule, let u equal to x, so u dash is 2, v equals e to the x, so v dash is still e to the x, so y dash is uv dash plus vu dash because that's the product rule. So y dash is 2x e to the x plus 2e to the x. So we need to differentiate this again. So this gives us y dash, the first derivative. We then need to work out y dash dash. This first term is product rule again, which we've actually worked out the derivative of, which is 2x e to the x there. So essentially y dash dash, well, the derivative of 2x e to the x is 2x e to the x plus 2e to the x. And we also need to add on the derivative of this tail end, which is 2e to the x, which gives us 2e to the x. So that tells us y dash dash is 2x e to the x plus 4e to the x. So that's the other key derivative there. Okay, so once you've got your original function, your first derivative and your second derivative, let's now look at step 1. So step 1 says find your x int, and that's when y equals 0. So your original function, so 0 equals 2x times e to the x. So using null factor law, that tells us that either 2x equals 0 or e to the x equals 0. So in other words, x equals 0, and the opposite of e base e is ln, but we can't ln 0, so this is not possible. So therefore, x-intercept at 0, 0. So that's one key information. X-int is at 0, 0. Step 2, work out your y-intercept. So y-int when x equals 0. So y equals 2 times 0 times e to the 0, which gives me 0. So it's the same point. Therefore, y-int at 0, 0 as well. Step 3, work out your stationary points. So stationary points, that happens when your first derivative equals 0. So 0 equals 2x e to the x plus 2e to the x, I believe. Yes, that was it. Let's factorize it now so we can apply null factor law. 2e to the x is in common. I can pull it out, and what's remaining is x plus 1. So again, using null factor law, that tells us 2e to the x equals 0 or x plus 1 equals 0. So e to the x equals 0, which is not possible. So that's not possible. So in other words, x equals -1. We need to check the nature using double dash. So check nature using y dash dash. So y dash dash of -1. So wherever x occurs in my double derivative, I put a -1 in. So that's 2 lots of -1 lots of e to the -1 plus 4 lots of e to the -1. So that gives us -2 lots of e to -1 plus 4 lots of e to -1. So that gives us 2 lots of e to the -1, which is approximately 2 times e to the -1, 0.736. 0.736, which is positive. So that's good. So that tells us it's a minimum, a happy face, because it's positive, or a concave up. So therefore, concave up, it's a happy face. Now when we want a point, we need the y value as well. So we need to work out the y value when x is -1. So y of -1 is 2 times -1 times e to the -1, which is -2 e to the -1, which is approximately -0.736. So that tells us that therefore -1, -2 e to -1 is a minimum, because it's a concave up, minimum turning point or stationary point. Okay, so I'm going to highlight that because that's not a key point. So we need to sketch that in later on. Let me just draw a border so we can write a bit more. Okay. So step 1, x int, step 2, y int, step 3, stationary point. In this case, we only have one stationary point when x equals -1, which we know is a concave up or a happy face, a minimum, because we checked using double derivatives. Step 4 is now looking for the point of inflections. So step 4, whoops, I'm the wrong pen, 4, point of inflection. That happens when y dash dash equals 0 and the concavity changes on either side. So we're trying to solve for y dash dash, so that 0 equals to do excuse me, 2x e to the x plus 4 e to the x, because that's the double derivative. Let's factorize it out. So 2 e to the x gives us x plus 2, whoops, plus 2 inside. So using null factor law, so 2 e to the x equals 0, or x plus 2 equals 0. So e to the x equals 0, which is not possible because you can't ln 0, or x equals -2. So let's check for concavity. So I need to drop a little table. So we're checking x values versus y dash dash values at the point x equals 2, a little bit to the left, so -2.1, and a little bit to the right, so -1.9. So I'm putting these numbers inside the y dash dash, so 2 times -2.1 times e to -2.1 plus 4 lots of e to the -2.1, which gives us, so 2 times -2.1 times e to the -2.1 plus 4 times e to the -2.1 gives us -0.02. So that's less than 0. Should be 0 at -2. And at -1.9, so 2 times -1.9 times e to the -1.9 plus 4 lots of e to the -1.9. So 1.9. 1.9, just typing this into a calculator. So that's 0.03. So that's definitely positive. So we do have concavity change on either side of -2. So therefore, concavity has changed either side of x equals -2. We want a point, so we need the xy value. So we need the y value when x is -2, because we're considering when x is -2. So that's the original y function. So it's 2 times -2 lots of e to -2. So that's -4 e to -2, which is approximately -0.541, just for sketching purposes. So therefore, -2, -4 e to -2 is a point of inflection. And we know that it's a point of inflection that goes from a concave down to a concave up. So it would look something like concave down to a concave up, like that. So we've got that point there, -2, and the corresponding y value. Next step, we're going to check the domain. So step 5, let's look at the domain. We're told that x has to be less than or equal to 1. So we can't sketch anything more than 1 to the right of 1. So because we do have a upper endpoint when x is equal to 1, we need to work out the corresponding y value. So we know what the endpoint is. So y value of 1 is 2 times 1 times e to the 1, which is 2e to the 1, which is approximately 1,5.437, just for sketching purposes. So therefore, endpoint is at 1, 2e to the 1. So we need to make sure we don't go past that point when we sketch. And then step 6, we look at the long-term behavior and asymptotes. So long-term behavior. So as x gets really negative and big, well, if we consider our function composes of 2x and e to the x, the product of that. So let's just even think about the normal exponential curve. What happens to the exponential curve as x gets really big and negative? Well, remember, your exponential curve looks like that, right? So as x gets really negative to the left, your y value, your e to the x, gets really, really close to 0. So we can say that as x approaches negative infinity, e to the x approaches 0. So therefore, as x approaches negative infinity, what happens to x, or what happens to 2x e to the x? So as x gets really big and negative, something really big and, well, 2x is still going to be something big and negative, but big and negative multiplied by 0 to 0 dominates, because anything times by 0 is 0. So essentially, this function approaches 0 as x gets really big. So it gets really, really close to the axis, but it won't ever cross the axis, because it won't be able to get back positive again, because your x value here is negative. So that gives us an asymptote which the function approaches, because it can't cross the x-axis from the left-hand side. So therefore, function approaches the x-axis because the y value is approaching 0. Axis, which will be a horizontal horizontal asymptote on the left side of the graph, because we're considering when x approaches negative infinity. And we don't really care about the right side because we've got the endpoint stopping us to go beyond anything to the right of x equals 1 anyway. On the left side of the graph. So let's sketch this thing. Okay, let's label our axes. We've got x and we've got y. In terms of points, my x value goes -1 and -2 to the positive value of 1. So I need to make sure I have enough space for that. So maybe if I go to, no, let's do that. It's -2. So that's -2, -4. Our y value goes from, well, I need to meet -0.7 or -0.54. Okay, so I need to go, let's make that -2. And then on the top, I need to go to 5.4. So if I go 2, 4, 6. Okay, so I've got 0, 0, which is my x int and y int. I've got -1, so that's about -1, -0.7, so that's about here-ish. So that's -1, -2, e to the -1, which is should be a smiley face. I've also got -2, sorry, -2, -0.5. So -2, -0.5 is about here-ish. Should probably use a different color. So that should be -2, -4, e to -2. I've also got the endpoint at 1, 5.4-ish, so that's 5. So 5.4 is about here. So that's 1, 2, e to the 1. Okay, so I know I've got a smiley face at this turning point down here. And it's gonna go through the, it's gotta go through the 0, 0 intercept. And it's gotta go all the way to the point of x equals 1. But I stop there because that's my domain. I can't go any more. I know that at the -2 point of inflection, it goes on the left, it's a concave down because it's negative, so it's kind of a sad face, and on the right of that point of inflection is a concave up, so a happy face. And that makes sense because on the right hand side I've got a happy face. It's not meant to be flat either because it's not a stationary point of inflection, so I shouldn't make that too flat. So let's see if I can draw this. And then we know that it's, and then we know that it should have an asymptote. So it should go, let me do that again. It's just not, should get closer and closer to the x-axis, but won't ever touch or cross the x-axis. I'll just cut it off there. And hopefully you can see that this point of inflection isn't too bad, that we have a concave down into a concave kind of shape. Yeah, that's not too bad. There we go. We'll leave it at that. So we need to finish off by labeling the curve. So y equals 2x e to the x. Our domain all your x values less than or equal to 1. Our range, so we can look at the range from our graph. Our lowest point is this turning point here, which is -2 e to the -1. And our highest point it will ever reach is this point here, because this is an asymptote. It will never ever cross the x-axis. It won't be able to get positive again. So our range is inclusive -2 e to the -1 and 2e to the 1 inclusive. That's it. So sketching curves following the 1, 2, 3, 4, 5, 6 step.